You're listening to Scientific Giants Who Changed the World. Each episode stands beside one mind and follows a thread of curiosity until it ties to the world we inhabit. Today we meet a man whose most famous discovery began not with brilliance or planning, but with clutter, neglect, and a willingness to look twice at something most people would throw away. His name is Alexander Fleming, and from a messy laboratory and a contaminated dish came penicillin, the first true antibiotic, and a turning point in the history of medicine. Alexander Fleming was born in 1881 on a small farm in rural Scotland. His early life was shaped by practical realities, hard work, limited resources, and an environment where survival depended on attention. He did not grow up surrounded by laboratories or academic privilege. He grew up learning to notice details, to make do, and to persist. Those habits would matter far more than genius alone. As a young man, Fleming moved to London and eventually trained as a physician. He joined St. Mary's Hospital Medical School, where he became part of a research group focused on bacteriology. This was a time when infectious disease dominated medicine. Before antibiotics, even small infections could kill. Surgery was dangerous. Childbirth was dangerous. A cut, a scrape, or pneumonia could become a death sentence. Doctors had few effective tools beyond sanitation and hope. Fleming was not a dramatic scientist. He was quiet, observant, and skeptical of grand claims. He had a particular trait that set him apart. He noticed what others ignored. He was not tidy. His laboratory was famously cluttered. Plates were stacked, samples were left out. This annoyed colleagues, but it also created conditions where accidents could happen, and where accidents could be seen, rather than erased. Before penicillin, Fleming had already made an important discovery. During World War I, he studied wound infections and realized that harsh antiseptics often did more harm than good. They killed bacteria, but they also damaged human tissue, making it harder for the body to heal. This insight pushed him toward the idea that the best antibacterial agents would be selective, able to kill microbes without harming human cells. In 1928, Fleming returned to his lab after a vacation. On his bench were petri dishes where he had been growing Staphylococcus bacteria. One of them had been contaminated with mold. This was not unusual. Most scientists would have discarded it immediately. Fleming almost did. But then he noticed something odd. Around the mold was a clear ring where bacteria refused to grow. The rest of the plate was cloudy with bacterial life, but near the mold, there was death. The mold was doing something the antiseptics could not do cleanly. It was selectively killing bacteria. But he understood its importance. He identified the mold as belonging to the genus Penicillium and named the substance it produced penicillin. He tested it and found that it was remarkably effective against many harmful bacteria and remarkably non-toxic to animal cells. This was the moment where history could have stalled. Fleming was not a chemist, and he struggled to purify penicillin. The substance was unstable and difficult to isolate. He published his findings, but they attracted little attention. Once again, science revealed a pattern that the world was not yet prepared to use. For years, penicillin remained a laboratory curiosity. In the late 1930s and early 1940s, with World War II looming, the need for effective treatments for infection became urgent. Scientists in Oxford, most notably Howard Florey and Ernst Boris Chain, returned to Fleming's neglected paper and recognized its potential. With improved chemical techniques, they managed to purify and mass-produce penicillin. The results were astonishing. Infections that once killed soldiers routinely were suddenly treatable. Wounds healed. Pneumonia became survivable. The antibiotic age began almost overnight. Penicillin spread rapidly, first through military medicine, then into civilian life. Life expectancy increased. Surgery became safer. Medicine crossed a threshold from managing disease to actively defeating it. Fleming himself was both celebrated and cautious. He warned early about antibiotic resistance, predicting that misuse would breed bacteria that could survive treatment. This warning was prophetic. Today, antibiotic resistance is one of the greatest threats to global health, a reminder that even miracle drugs carry responsibilities. Fleming never patented penicillin. He did not seek to control it or profit from it. Like Salk after him, he saw it as a public good, a discovery that belonged to humanity rather than an individual. So how should we remember Alexander Fleming? Not as a lone genius who single-handedly saved the world, but as a man whose greatest skill was attention. Fleming did not invent penicillin in the sense of designing it. He noticed it. He trusted the evidence of an accident and refused to clean it away before understanding it. He represents a kind of scientific humility, the willingness to let nature interrupt your plans. His story also reminds us that discovery is rarely enough on its own. Fleming needed others, chemists, clinicians, industrial engineers, to turn penicillin into medicine. Scientific revolutions are almost always collective, even when they begin with one pair of eyes. If you want a final image, picture a cluttered bench and a forgotten dish, a circle of clarity and a field of bacterial fog. Picture Fleming pausing, leaning in, and choosing curiosity over routine. In that pause, millions of lives were quietly saved. You have been listening to Scientific Giants Who Changed the World. Today we followed Alexander Fleming from rural Scotland to a messy London lab, from accidental contamination to the birth of antibiotics, from observation to global transformation. In our next episode, we will meet Frederick Banting and Charles Best, two young researchers who wrestled insulin from the pancreas and changed diabetes from a death sentence into a life that could continue. Until then, thank you for your attention and your time. This episode was written as a continuous story for the ear, because Fleming's discovery was not a moment of brilliance alone, but a moment of restraint. The decision not to throw something away before listening to what it had to say.